You can solve a system of two linear equations three ways. The first way is by graphing. If you have a graphing calculator, that's the easiest way. Graph the two equations, see where the two lines meet. Another method is what's called the substitution method. Substitution method, when you're solving a system of two linear equations, is wanting to get one of these equations to read x equals or y equals and then substituting into the other equation. So you want to get one of these equations solved for x or y. Now this y I see does not have a number in front of it, so that's the one I want to aim at. That's the variable that I want to get by itself. So I want to solve that second equation for y. To do that, simply subtract 2x from each side. So now when you have that solved for y, it says y equals negative 2x plus 10. We're going to substitute that negative 2x plus 10 into the other equation for y, because it says y is negative 2x plus 10. So take that negative 2x plus 10, substitute that in for y into that first equation. So take the first equation, you're now replacing the y with the negative 2x plus 10. You're not replacing the 4 and the y, just the y. So it's 4 times negative 2x plus 10. So for that first equation now, it's 3x plus 4 times negative 2x plus 10 equals 12. Once again, got that second equation to read y equals. I solved that for y. I isolated that variable. Took that negative 2x plus 10, substituted that back into the first equation for y. So now I have this one equation with one variable. I can solve this equation for x. So the quickest I can get to solving for x and y, the better. Use distributive property with the 4. So I'm solving that equation for that variable x. Distributive property with the 4 makes that negative 8x plus 40. So 3x minus 8x plus 40 equals 12. Continue solving for x. Combine the like terms. 3x and negative 8x would be negative 5x plus 40 equals 12. Subtract 40 from each side. Get negative 5x equals negative 28. And then divide each side by negative 5. X is equal to 5.6. So that's telling you right there that the x coordinate of the point of intersection of these two lines is 5.6. And now that we know x is 5.6, we can solve for the other variable, solve for y. So you want to go back to any equation up here that has an x and a y in it. You can substitute 5.6 in for x and solve for y. So we're substituting the value of the variable into one of the equations and solving for the remaining variable. So now that we know x is 5.6, put that in anywhere up here where there's an x and a y, and you can solve for y. The best equation, since you're solving for y, is where it already says y equals. This y equals negative 2x plus 10. Substitute 5.6 in for x. So it'd be y equals negative 2 times 5.6 plus 10. So now we're on our way to solving for y. Negative 2 times 5.6, that is negative 11.2. Then combine negative 11.2 and 10. If you add those, it's negative 1.2. So that negative 1.2, that's the y coordinate of the point of intersection of these two lines. So these two lines meet at 5.6 and negative 1.2. And if you graph these on a graphing calculator, these two lines, you can see they do meet at the point 5.6 and negative 1.2. So solving this system of equations for x and y, x equals 5.6 and y equals negative 1.2. We're going to use the substitution method again to solve this system of equations. X plus 3y equals 5 and negative 2x minus 4y equals negative 5. So that is a system of two linear equations. The graphs of them would form straight lines. What we're finding is the point of intersection where those two lines meet, the point of intersection of those two lines. So if you're using the substitution method, you want to get one of these equations to read x equals or y equals. So isolate either the x or the y in one of these equations. And you want to look for either x or y that does not have a number showing in front of it. That's the easiest variable to isolate. So right there, that x with no number showing in front of it, if I simply subtract 3y from each side, that equation would become x equals negative 3y plus 5. So now that's saying that x is negative 3y plus 5. I'm going to take that negative 3y plus 5 and substitute that into the other equation, not the same equation. That would cause problems. I'm going to substitute that into the other equation for x. So I'm replacing the x in that second equation with this negative 3y plus 5. So I'm taking out the x, not the negative 2x, just the x. So replace the x with negative 3y plus 5, and now if you see, I have one equation with one variable. I can solve that equation for y. So to solve that for y, use a distributive property with the negative 2. That becomes 6y minus 10 minus 4y equals negative 5. Combine the like terms, 6y and negative 4y, that makes 2y minus 10 equals negative 5. Add 10 to both sides, get 2y equals 5, and then divide each side by 2. Y equals 5 halves, or in other words, 2.5. So that 2.5, that is the y coordinate of the point of intersection of these two lines. You still need to find x. So to find x, take that 2.5, substitute it back in for y anywhere up here where you see an x and a y. So any equation with an x and a y in it, you can put that 2.5 in for y, and then you can solve for x. The best equation, since you're solving for x, is where it already says x equals. Use that equation, x equals negative 3y plus 5. So take that 2.5, substitute it in for y, and you'll have x plus 3 times 2.5 is equal to 5. And then continue solving for x, multiply 3 by 2.5, that is 7.5. So x plus 7.5 equals 5. Subtract 7.5 from each side, and you get x equals negative 2.5. So that negative 2.5 is the x coordinate of the point of intersection of these two lines. And you can see that, if you graph that on a graphing calculator, you can see those two lines meet at negative 2.5 and positive 2.5. So when solving this system of equations, the point of intersection, x equals negative 2.5 and y equals positive 2.5. We're going to solve this system of equations using the substitution method. So again, when you're using the substitution method, you want to get one of these equations solved, in this case, for a or b. Well, that second equation already says b equals 2a plus 1. So if b is 2a plus 1, simply take that 2a plus 1, substitute that into the top equation for b, and then you'll have one equation with one variable, and you can solve that equation for a. So take that 2a plus 1, substitute that in for b into that first equation. So we're just replacing the b. The 2 is still there. This is 2 times 2a plus 1 because b is 2a plus 1. So we have 4a plus 2 times 2a plus 1 equals 8. We can solve that equation for a. Use a distributive property, take 2 times 2a, it's 4a, and 2 times 1 is 2. So 4a plus 4a, that is 8a. 8a plus 2 equals 8. Subtract 2 from each side. End up with 8a equals 6, and then divide each side by 8. A equals 6 over 8, that'd be 3/4 or 0.75. So a equals 0.75. That is the a coordinate of the point of intersection of these two lines. Just like an x and a y coordinate, x and y axis, you would have an a and b axis in this case. You still need to solve for b. So we have to find out what b is. Well, you can take that, now that you know a is 0.75, you can take that and substitute it in anywhere up there where there's an equation with an a and a b in it. The best equation, since you're solving for b next, is to use this equation right here. B equals 2a plus 1. You know that a is 0.75, so replace the a, not the 2a, just replace the a with 0.75. So now b is 2 times 0.75 plus 1. 2 times 0.75, that is 1.5, so b equals 1.5 plus 1, and therefore b equals 2.5. So the point of intersection of these two lines, a is 0.75, b is 2.5. Just like you have an x-axis and a y-axis, the a-axis, 0.75, the b-axis, 2.5. So the point of intersection of these two lines is 0.75, 2.5. So we solve that system of equations, a equals 0.75, and b equals 2.5. So we've solved the system of equations by graphing. You graph the two lines, see where they meet. We've solved by substitution, where you get one of the equations to read x equals or y equals or solve for one of the variables and then substitute into the other equation. The third and final method to solve a system of two linear equations is by what's called the elimination method. Some may refer to it as the addition method. The goal of this is to be able to add the two equations together and eliminate one of the variables. Well, looking at these two equations, you can see if you add them together, add the x's, add the y's, and add the constant terms, the x's will cancel. That's what you want to have happen. You want one of the variables to disappear so that you can solve for the other variable. So the first step would be to, if you can, add the two equations together. Now, sometimes it's not that easy. Sometimes you will have numbers that do not cancel simply when you add them together. So you may have to multiply the top or bottom or both by something. So then when you add them together, one of the variables will cancel. But in this case, the x's do cancel. You add 2y and 3y, it's 5y. 9 and 16 is 25. So the x's canceled, we have 5y equals 25. You can easily solve that equation for y. Divide each side by 5, and you end up with y equals 5. So add the two equations together, unless you have to multiply by something. Add the two equations together in order to eliminate one of the variables, and then solve the remaining equation for that variable that's still there. So we have y equals 5. That is the y-coordinate of the point of intersection of these two lines. We still need to find the x-coordinate of the point of intersection so we can see where these two lines meet. So now that we know y is 5, take that 5, substitute it in anywhere up here where there's an x and a y. Now, neither one of these says x equals. So unlike the substitution method where you may have an equation that says x equals and you just substitute back in, that's not the case here. So you have a decision to make. What's the best equation to use? What's the easiest equation to substitute back into? So by easy, I mean no negative numbers, no big numbers, no fractions, of course. 4x plus 2y equals 9, that looks pretty easy. There are no negative numbers. Those numbers aren't too big. So let's go into that one. Put 5 in for y into that first equation. Any equation up there you could have used. So if you want to live life on the edge, go into the second equation because that has a negative sign. So substitute 5 in for y, it'd be 4x plus 2 times 5 equals 9. 2 times 5 is 10, it'd be 4x plus 10 equals 9. Subtract 10 from each side to get 4x equals negative 1. And then divide each side by 4, x would equal negative 1/4, or negative 0.25 as a decimal. That is the x-coordinate of the point of intersection. 5 is the y-coordinate of the point of intersection. So these two lines behind me are meeting at the point negative 0.25 and 5. You can see when you graph those two equations, they meet at the point negative 0.25 and 5. That is the point of intersection of those two lines. X is negative 0.25, y is positive 5. Going to use the elimination method to find the solution of this system of equations. Again, we have two lines. We want to find out where these two lines meet. Now, the elimination method, remember, we want to add these two equations together and hopefully cancel out one of the variables. But if you look at these two equations right now, if you add those together right now, neither one of the variables would cancel out. If you add the x's, that'd be 2x. If you add the y's, that'd be 3y. So neither one of the variables will cancel. Could you subtract these two equations? Of course you could. You could subtract the two equations. You'd have y equals 4. It's perfectly fine, but some people seem to make mistakes, especially when there's negative signs involved. They seem to make mistakes on the subtraction, so you may want to stick with addition. And in order to do that, we're going to multiply one of these equations by negative 1, so that we have one of those x's being negative and the other one being positive. So that bottom equation, I'm going to multiply that bottom equation by negative 1. When you multiply by negative 1, make sure you multiply each term, including the 6 after the equals sign, by negative 1. So it'd be negative x minus y equals negative 6. I'm going to take that with the first equation. I'm going to put those two equations together. Now when I add those together, the x's are going to cancel. So now I have an x and a negative x. Those will cancel. Then I'll be able to solve for y. So 2y plus a negative y, that is y. 10 plus a negative 6, that is 4. So y equals 4. Now I told you at the beginning, you could subtract those. X minus x, then cancel. 2y minus y, that would be y. 10 minus 6 is 4. Same thing you get right here, y equals 4. So you can subtract these from the beginning and get one of the variables to cancel. But again, when you have negative signs involved, some people tend to make mistakes when there are negative signs and you are subtracting. So you may want to stick with multiplying one of them by negative 1 and then adding the two equations together. Y equals 4, that is the y-coordinate of the point of intersection of these two lines. We still need to find the x-coordinate. So take that 4, substitute that in for y, anywhere up here where there's an x and a y. So any equation up here is open game to substitute 4 in for y. You want to pick an equation that's easy to work with. Small numbers, no negative signs. I think that x plus y equals 6 looks pretty easy to substitute into and work with. So I'm going to substitute that 4 in for y into x plus y equals 6. So I'm replacing the y with the 4. You have x plus 4 equals 6, and then solve that equation for x. Subtract 4 from each side, x equals 2. So x equals 2 and y equals 4. That is the point of intersection of those two lines. They meet at the point 2, 4. We're going to solve this system of linear equations using the elimination method. 2x plus 7y equals 4 and 3x plus 5y equals negative 5. A little bit of a problem here because you can't just add these two equations together and cancel out one of the variables. You can't just subtract them and cancel out one of the variables. Because you have a 2x and a 3x, a 7y and a 5y. So here's a case where you may have to multiply the top, bottom, or both equations by something so that one of the variables will cancel when you do add those together. So if you look at the x's, you have a 2x and a 3x. The 2 and the 3. You want to think, what's the least common multiple of 2 and 3? What's the smallest number that you can multiply the 2 to get and the 3 to get? In other words, 6. If you multiply 2 by 3, it's going to be 6. Multiply 3 by 2, it's going to be 6. So you could change one of those into 6x and the other one into negative 6x so that when you add those, the x's will cancel. Or look at the y's. A little bit bigger numbers here, but you can change the y's into 35y and negative 35y so that when you add those together, the y's will cancel. So either change the x's to be the same, change the y's to be the same, make sure one of them is positive, one of them is negative, so that when you add these two equations together, one of the variables will cancel. So instead of going to 35y and negative 35y, I'm going to stay small. I'm going to go with 6x and negative 6x. So that top equation, if I multiply that top equation by 3, that'll be a 6x plus 21y equals 12. If I multiply the bottom equation by negative 2, that changes that into negative 6x minus 10y equals positive 10. Make sure when you're multiplying by something that you multiply each term by it. So in other words, in that first one, a lot of times people will still have a 4 there. They'll forget to multiply what's after the equal sign, in this case by 3. Or in the bottom equation, they'll forget to multiply the negative 5 by 2, and they'll still have a negative 5 there instead of a 10. So we multiplied the top by 3, the bottom by negative 2. Now we have a 6x and a negative 6x. Those two equations are ready to add and cancel out the x's. So if we do add these together, the x's will cancel. 21y plus a negative 10y, that's going to be 11y. And 12 and 10, if you add those, it's 22. So 11y equals 22. Divide each side by 11, y equals 2. So we know the value of one of the variables, y is 2. We still need to find the value of x, because that's just the y coordinate of the point of intersection of these two lines. To find the value of x, take that 2 and substitute it in anywhere up here where there's an x and a y. But be smart, be strategic where you're substituting that into. You probably don't want to go into these because these are big numbers, more chance of making a mistake. You want to go into something that has small numbers, stay away from negative signs if you can, stay away from fractions if they're there. Substitute 2 in for y. I'm going to substitute that into this bottom equation. Now that does have a negative sign with it. It should be fine. So I'm replacing the y, not the 5y, just replacing the y with this 2. So now I have 3x plus 5 times 2 equals negative 5. Multiply 5 by 2. It's going to be 10. So 3x plus 10 equals negative 5. Subtract 10 from each side. Get 3x equals negative 15. And then x equals negative 5. So the x coordinate of the point of intersection, which is behind me, is negative 5. The y coordinate of the point of intersection is 2. Those two lines meet at the point negative 5, 2. So if you're asked to solve this system of equations, x equals negative 5 and y equals 2.